Hello, my name is Chelsea Swan, Product Marketing Engineer with DLP at Texas Instruments. Today we are taking a deeper look into the DLP NIRscan EVM optics architecture and considering some design alternatives for your spectroscopy applications. Remember, if you decide to make changes to the NIRscan, you will void your warranty for the EVM. Let's start by looking at the light engine. Using a 2mm hex screwdriver, take off the 4 screws on the top of the EVM. We start with the light source of the NIRscan, which utilizes a tungsten lamp that outputs a broadband infrared light in the desired region. The wavelengths needed for your application will determine your light source. The light then passes through the transmittance sample holder. The 3 cuvettes included with the NIRscan EVM can be used for liquid samples, which are mostly transparent in the infrared. Diffuse reflectance measurement techniques are used for samples which are usually more opaque. These require a diffuse reflectance sample module, which is not included with the NIRscan. The light passes through the sample and is refocused through a 25-micron slit. The slit provides a geometrically sharply defined source of light, which then shines on the diffraction grating. The width of the slit preceding the grating in the optical path is the key factor in determining the wavelength resolution of the acquired spectrum. Wider slits, such as 50 microns, allow more light through for faster scans and/or higher sensitivity. Smaller slits, near 10 microns, trade off light throughput for improved wavelength resolution. Collimated light passes a bandpass filter, and the diffraction grating reflects each of the wavelengths of light at precisely different angles. Prisms are sometimes used for dispersion, but diffraction gratings are more commonly employed because of their higher dispersion and their ability to be optimized for a wide range of optical wavelengths. Either reflective or transmissive diffraction gratings can be used, and the wavelength range of the gratings determine the acquired spectrum and types of materials that can be scanned. If curved gratings are used, the focus lens after the grating can be eliminated, which may offer advantages for system robustness and/or cost. The light is then focused and dispersed as a spectrum of light spread horizontally across the mirror array of the DLP digital micromirror device. The 0.45 WXGA NIR DMD in the EVM is optimized for wavelengths of 700 to 2500 nanometers, and the NIRscan optics design optimized the EVM for 1350 to 2450 nanometers. Various DLP chipsets are available, with different DMD array sizes, resolutions, maximum pattern rates, optimized wavelength ranges, and other specifications. The best choice for a DLP chipset would depend on the spectroscopy system requirements, such as the range of wavelengths to be measured, the desired wavelength resolution, the speed of acquisition of the spectrum measurement, and more. Columns or mirrors are turned on to select the desired wavelengths to be measured across a single element detector. The data from the detector is then captured by the system electronics. Electronics design alternatives may be considered with the AD converter, the TEC driver, and the embedded processor. A system must have a low noise detector amplifier and an ADC to achieve high signal-to-noise ratio values. For a single pattern displayed on the DMD, multiple samples can be collected from the ADC in order to lower noise by averaging. A typical system will use a 16 or 24-bit ADC at sampling rates in the tens of kilohertz or higher, depending on the application needs. The NIRscan's Satara embedded processor commands the DMD controller, the lamp driver, and the processing speed. Pattern and pattern speed can be adjusted if the spectroscopy application requires scanning certain wavelength ranges or areas of the sample for a longer or shorter time. The TEC driver board keeps the detector at a low temperature to decrease inherent detector noise and stabilizes the temperature so that responsivity is constant throughout the entire scan. For extended in-gas applications where wavelength ranges reach 2500 nanometers, a cooled detector is required for good performance. The TEC driver board can be removed for standard in-gas detectors where the system's wavelengths are limited to 1700 nanometers maximum. High-performance visible spectrometers commonly employed cooled silicon detectors as well. More questions about the DLP NIRscan? Please visit ti.com/DLP NIRscan. Thanks for watching.